go for the radial feeder, that is sectionalized radial feeder, radial primary feeder with the sectionalized tie switch, then express feeder and back feeder, so area feeder and loop feeder also. After then discuss about the voltage level in a radial primary feeder. Voltage level in a radial primary feeder, and then design practice of a practical design of secondary distribution system and secondary banking system and mathematical application of AC distribution system. But power factor refer to sending end voltage, power factor refer to the receiving end voltage, right? So this is about second unit. Now coming to the third unit, substations. So classification of substation, difference between the overhead and underground substations, and also location of the substation, optimal location of the substation, rating of the substation according to square shaped network and hexagonal shaped network. Next, n number of primary feeders, a generalized rating of the distribution substation with n number of primary feeders, and 4 and 6 feeder pattern comparison between the 4 and 6 feeder pattern, all these important. Next, bus bar concept, single bus bar with sectionalization, single bus bar or double bus bar with single breaker, main and transfer bus bar, and 1.5 breaker bus bar systems, right? So now that is about third unit, substations. Now go for the fourth unit, so that is power factor improvement. Generally they given the title power factor improvement, but so in this unit, so many topics are there, that is voltage control of distribution system for 3-phase system or single phase systems, and also so many things. Next, power factor. What are the causes of low power factor? What is the power factor definition? What are the causes of low power factor? What are the disadvantages of power factor? How to improve the power factor? What are the methods are available in power factor improvement? Then what is the condition for maximum kVA? I mean maximum most economical power factor condition, and then derivation of most economical power factor when constant kilowatt is available. Most economical power factor when constant kVA are available. Two derivations, and some problems on power factor. That is power factor correction. Then voltage control for single phase, 3-phase balanced systems. Single phase and 3-phase balanced systems, and also uniform distributed load systems. Then economic concept of capacitor, that is shunt capacitor and series capacitor concepts, and also improving methods of voltage drop, that is improving methods of voltage control, that is so many methods available. After then economic concept of capacitor location, then a best procedure, otherwise a procedure for best location of capacitor. So these are the topics of fourth unit. So a big unit compared to all units. So many, maybe 2 to 3 week classes are applicable to this unit. So now I am going to the actual topics of today class, that is fourth unit of EDS electrical distribution system, that is power factor improvement. So now generally what is the power factor? So as till now, as you know that power factor Power factor is nothing but a cosine angle between the voltage, and current, right? So generally for network systems, cos theta is nothing but power factor. Cosine angle between voltage and control is nothing but power factor. The range of power factor is 0 to 1. Minimum value of power factor is 0. Maximum value of power factor is 1. So right. So for a good voltage profile, for a reliable power supply to the, you have to distribute the reliable power supply to the consumers. Quality of supply is given to the consumers, such that we may maintain a good power factor, that is nothing but nearly equal to 1. Then only we are getting a good quality of power given to the consumers. That means, so every industry, suppose in our college also, just we have to observe what is the active power, what is the reactive power, and what is the power factor. The power factor of the institution is more than the 0.98. So it may be a good power factor. That means you have to maintain 0.9, 0.98, 0.97 or 0.99, then it may be a good one. Suppose maybe less than the 0.7 or 0.8, or it may be less than the 0.5. So that may be low power factor. You can term it as a low power factor. Because of low power factor, so many disadvantages will be there. Generally, what is power factor is nothing but, power factor is the cosine angle between voltage and current. Otherwise, we can define in terms of powers. So you have to draw a power triangle, that is real power, reactive power, apparent power. Real power, so, and reactive power, apparent power. Now the definition of power factor is nothing but, it is the ratio of active power to the apparent power. It is the ratio of active power to the apparent power. Active power is nothing but kilowatts. Apparent power is nothing but kVA, right? So look at the power factor is the measure of how effectively electrical equipment converts electrical power into useful power output. That means our all auxiliary equipments may running with electrical power supply. So whenever we are giving a good quality of power factor to the consumers, that means the auxiliary equipments or equipments in the house, or it may be industry, may running smoothly and may give best quality, best output of their operation. That means the lifetime of the equipment is also improved. When our power factor may be good for a particular system or particular industry or particular house, that means the equipments in particular house or industry may run smoothly and may give lifetime is also more and more, right? So generally, so in electrical network or electrical circuits, we may define the power factor is nothing but, power factor is the cosine angle between voltage and current. So the maximum value is 1, minimum value is 0. So right, it may be lagging or leading or unity power factor, depending upon the, suppose it is a resistive network, power factor is unity. If it is a, that means voltage and current both are in phase. For resistive network, voltage and current both are in phase. There is no angle. Pi is theta is 0. That means cos 0 is 1. So that's why for resistive network, so unity, they maintain unity power factor. For inductive networks, so that means inductive network is nothing but current is lagging with some angle by voltage. That is nothing but voltage reference, and current is lagging voltage by some angle. That is nothing but it is a lagging power factor. Coming to the capacitive network, current is leading voltage by some angle. Current is leading. So that means capacitors having leading power factors. So these are all already studied in the electrical circuit subject. Now coming to the our distribution system. So we don't take the definition of cosine angle between voltage and current. So suppose we have to, what is power factor means, someone will say that cosine angle between voltage, that is not false, correct. But coming to the distribution system, we don't define power factor is nothing but cosine angle between voltage and current. Just we have to define in terms of powers, that is ratio of active power to apparent power. Active power to apparent power, that is nothing but kilowatt by kVA, right? So generally the angle between the voltage and current is negative. Then the cosine angle is for lagging power factor. Angle is negative is nothing but the angle is more than 90 degrees, right? So suppose below 90, 0 to 90, the cos 0, 1, cos 90, 0, greater than 90, negative values. That means lagging power factor. Suppose if it is a current lags behind the voltage and the power factor suffers the refers to the lagging power factor. Similarly, the power factor is having positive values means leading power factor, that is capacitive nature, right? So power factor is the definition of active power to apparent power, kilowatt by kVA. That means, so we may write kilowatt is equal to kVA into cos pi. So we may write real power to total power or apparent power. So from this, kilowatt is equal to kVA into power factor is nothing but cos pi. Otherwise, we may write kVAR. So suppose from the diagram we have to from the power triangle diagram, cos pi is equal to active power by apparent power. What about sin pi? Sin pi is nothing but opposite by hypotenuse. Opposite is nothing but reactive power. So reactive power by apparent power, that is kVAR by kVA. So therefore kVAR is equal to kVA into sin pi. Like that we have to solve the problems also. From the power factor definition, we determine the kilowatt. Kilowatt is equal to kVA into cos pi. Power triangle diagram, kVAR, that is reactive power. Reactive power is equal to kVA into sin pi. Right? So now generally, what are the causes of low power factor? Why generally less than 0.8 or less than 0.7 we may consider it as low power factor. Because of that low power factor, so many problems will be there. I will discuss next slide. But first of all, what are the causes of low power factor? So ఎందుకు వస్తుంది పవర్ ఫ్యాక్టర్ తక్కువ అనేది? So that is nothing but generally low power factor is undesirable from the economic point of view. So low power factor is undesirable for economic point of view is nothing but suppose because of low power factor our auxiliary equipments may consume more power, that may release losses. That means so unit for cost is increases. Number of units will be consumed by the consumer is more. That means so the cost will be increases, right? So normally power factor of all load on the supply is lower than the 0.8 or it may be 0.7. So then we say that the given power factor is low power factor. So power factor is 0.8 or 0.7. In textbooks 0.8, generally 0.7. So suppose less than 0.8 we can consider as low power factor, right? So mainly, what are the main causes? So main causes of low power factor is most of the motors are induction type, right? So suppose we are using in our house or agriculture purpose or any industries. So most of the motors may utilized in the outside of the world is inductive nature volts. So that means so induction motor is nothing but coil. What is the principle of operation of induction motor? It may be electromechanical energy conversion, right? So look like as a induction motor is look like as a transformer, right? Transformer is nothing but inductive coil. Primary winding, stator will act as a primary winding, rotor will act as a secondary winding. That means so inductive nature. So induction motor, most of the motors used in the practical purpose is induction motors. Induction motors are inductive nature. And second point is transformers have low lagging power factor because they draw magnetizing current. So suppose transformers are also inductive nature, but Because of low power factor, they will draw more magnetizing current, I mu. Because of magnetizing current, the leakage currents are developed in the primary winding more and more. That may damage the primary winding also. So that's why the transformers are lagging power working of lagging power factor when so it will drawing the more magnetizing current, right? So before going to the another one, why induction motors are working on low lagging power factor means, so it may works very low lagging power factor on the light load condition. Light load condition daggara avi chaala takku power factor daggara pani chestayi. That may be numerically equal to the 0.2 or 0.3 generally. 0.2 or 0.3 పవర్ ఫ్యాక్టర్ వాల్యూస్ దగ్గర అవి వర్క్ చేస్తాయి కాబట్టి సో అవి లో దగ్గర వర్క్ చేస్తున్నాయి. ఎప్పుడు నో లోడ్ కండిషన్, సపోజ్ ఫుల్ లోడ్ కండిషన్లో 0.8 సో బిలో 0.8, దట్ ఈస్ వై సో ఇండక్షన్ మోటార్స్ ఆర్ వర్కింగ్ ఆర్ low lagging power factors. Next one is induction generators, that is windmill generators. Generally, what is the slip of when slip is greater than 1? Slip is greater than 1. So slip is negative means it may be going to the breaking. Suppose slip is more than 1. More than 1 is nothing but the rotor speed is very greater than the synchronous speed, right? So that may at that time the induction motor may act as induction generator. So these are, that is nothing but that may be a inductive circuit. Next, discharge lamp, high intensity discharge lamps. So that means so electric lamps, sodium vapor lamp, or it may be mercury vapor lamp, or lamps or electrical discharging lamps are working at low lagging power factor. And also welding, in welding, resistance welding, butt welding, మీరు ఆల్రెడీ UW చదువుతుంటారు. సో welding equipments also working at the low power factor. These are all causes of the low power factor. What are the causes of low power factor? Is nothing but induction motors, transformers, induction generators, discharging lamps, electric arc furnitures also, right? Because of all these systems, the power factor may be low. Now, what are the disadvantages of low power factor? So, ఈ low power factor causes ఎందుకు వస్తున్నాయి? ఇండక్షన్ మోటార్ వల్ల, ట్రాన్స్ఫార్మర్ వల్ల, ఇండక్షన్ జనరేటర్ వల్ల, ఎలక్ట్రిక్ డిశ్చార్జ్ ల్యాంప్ వల్ల, వెల్డింగ్ ఎక్విప్మెంట్స్ వల్ల, ఎలక్ట్రిక్ ఆర్క్ ఫర్నిచర్స్ వల్ల, like that all these devices may cause to power factor may be low. సో ఈ పవర్ ఫ్యాక్టర్లో ఆ ఎక్విప్మెంట్స్ పనిచేయడం వల్ల వచ్చే నష్టాలు ఏంటి? దట్ ఈస్ నథింగ్ బట్ ద డిసడ్వాంటేజ్ ఆఫ్ లో పవర్ ఫ్యాక్టర్. కాజెస్ ఆఫ్ లో పవర్ ఫ్యాక్టర్, దిస్ వన్. సో రియాక్టివ్ పవర్ రిక్వైర్డ్ ది ఇండక్టివ్ లోడ్స్ ఇంక్రీజెస్ అండ్ అమౌంట్ ఆఫ్ అపరెంట్ పవర్ ఇస్ డిస్ట్రిబ్యూషన్ సిస్టమ్. ఎప్పుడైతే రియాక్టివ్ పవర్ ఇంక్రీజ్ అయిందో, సో ద యాంగిల్ ఈజ్ ఇంక్రీజెస్. when angle increases, what about power factor? Power factor decreases. Cos 0 1, cos 90 0. Power factor decreases. So look at the figures. So at the first slide, I am defining the power factor. Power factor is the ratio of active power to apparent power. So this is, look at the figure 6.2. So this is OA is the active power, that is VI cos pi, so in kilowatt. AB is the reactive power, VI sin pi, that is measured in kVAR. Now OB, that is VI, so this is the apparent power or total power. Now take, this is the angle. Now take the cos pi. Cos pi is nothing but adjacent by hypotenuse, that is VA by VI, there is nothing but cos pi. So active cos pi is equal to active power by apparent power. Suppose taking the sin pi is nothing but opposite by hypotenuse. Vi sin pi by Vi, that is nothing but sin pi. So it is reactive power is the ratio of, so reactive power to apparent power. Simply say that cos pi is the active power to apparent power. Is the another definition of also is there in the power factor. Generally, power factor is defined as the cosine angle between the voltage and current, and it is a ratio of active power to apparent power. Is again another formula is also in electrical circuits already you have studied. That is mainly studied this definition mainly studied in the resonance condition. Resonance condition. At resonance condition, circuit may behave as a resistive. That means unity power factor, right? So again, in series resonance circuit, the impedance must be equal to R. Impedance must be equal to R is nothing but R by R, 1, right? So that is the another definition. Power factor is the ratio of resistance to impedance. Power factor is the ratio of active power to apparent power, right? Or real power to apparent power, active power or real power or true power to apparent power, right? Now, going to the disadvantage of low power factor. Because of low power factor, what will happen? So generally, power factor may play the important role in AC circuits since power consumed depends on the power factor. So, what is the power formula? Root 3 VL IL cos pi for 3 phase. For single phase, P is equal to VL IL cos pi. So from that, first derive the load current or line current, that is IL is equal to P by VL cos pi for single phase. IL is equal to P by root 3 VL cos pi for 3 phase. Right? If it is clear that from the above equations, for a fixed power and voltage, the load current is inversely proportional to the power factor. Suppose by observing the line current of single phase or 3 phase, for a fixed voltage and power, P and VL are constants such that IL is inversely proportional to power factor. Here also IL is inversely proportional to power factor. So now, so the factor is that the load current, it will be very high. It may lead to the following effects. That means load current ఎక్కువైనప్పుడు పవర్ ఫ్యాక్టర్ తగ్గింది అనుకోండి, లోడ్ కరెంట్ పవర్ IL is inversely proportional to cos pi. If power factor is low, is nothing but IL is very high, right? If IL is very high, what will happen? First one is copper losses, right? So that is I square R losses. If the power factor of the system is poor, then the load current drawn from the supply is high, which may cause very high copper losses, that is I square R losses, and as a result, efficiency also poor. Copper losses, ఎప్పుడైతే పవర్ ఫ్యాక్టర్ తగ్గిందో లోడ్ కరెంట్ ఇంక్రీజ్ అవుద్ది, ఎప్పుడైతే కరెంట్ ఇంక్రీజ్ అయిందో I square R losses ఇంక్రీజ్ అవుతాయి. I square R losses ఇంక్రీజ్ అయితే ఎఫిషియన్సీ తగ్గిపోతుంది, సిస్టమ్ పెర్ఫార్మెన్స్ decreases. So next one is effect on voltage regulation. In alternators or transformers or transmission lines, the current at low lagging power factor cause very high voltage drops, right? Power factor తక్కువైతే కరెంట్ ఎక్కువ అవుతుంది, కరెంట్ ఎక్కువైతే డ్రాప్ IaRa drop is increases. Whenever IaRa drop is increases is nothing but, so this may damage the device. In order to overcome the surprise voltage regulators, to regulate the voltage in a required manner. That means all our auxiliary equipments may work with plus or minus 6% of rated voltage. What is the rated voltage? Generally 230 volts for AC systems. Now under that 230 volts, plus or minus 6% is rated value, that is 230 plus or minus 6%. So 230 plus or minus 6 by 100 into 230, that is 14. Suppose you can consider 14 volts. That means 230 minus 14, 230 plus 14. So 230 minus 14 is nothing but 216. 230 plus 14 is nothing but 244. That means 216 volts to 244 volts is the reasonable voltage. In between these two voltages, our all auxiliary equipment is conveniently working. Suppose the voltage may be dropped less than the 216 or voltage may be high more than the 244. At that time, the voltage fluctuations will be developed. Because of that voltage fluctuations, the voltage regulation will be reduced. Voltage fluctuation means minimum voltage, maximum voltage. The difference is more. Whenever Vs minus Vr is more is nothing but regulation is down. What is the definition of regulation? Voltage regulation. Difference between the sending voltage difference between sending end voltage and receiving end voltage, and it is expressed as receiving end voltage. Vs minus Vr is low is nothing but voltage regulation is low. There is nothing but poor voltage regulation. Right? So to overcome that voltage regulation problem, we may utilize separate regulators. Generally, all are buying with every equipment. We may buy the V-guard stabilizer, or so many companies are there. We can buy the stabilizers. That stabilizer may stabilize in between safe voltage, in between the required voltage, that is 216 to 244. Suppose the voltage may be high, that is more than 250, more than 250. At that time, it may reduce the voltage and may put into the safe value. Right? Suppose voltage may be go to the low value at that time also, so it may increase the voltage and may put into the safe value. That is nothing but so to reduce the voltage fluctuations and may give the required voltage to the auxiliary equipment. That is nothing but auxiliary equipment may utilized or may perform in a normal manner. Right? Large copper loss, poor voltage regulation, large kVA rating. Right? Now next one, greater conductor size. Greater conductor size, that is nothing. Load current is inversely proportional to the power factor. Hence, having low power factor, then the transmitting fixed amount of power at a constant voltage. The conductor we have carrying more current, then it required large cross-sectional area. Therefore, low power factor required greater conductor size, which may increase the cost and decrease the efficiency. That means, so we have to load current is inversely proportional to the power factor. Power factor is low is nothing but load current is high. To carry that much of high current, we may use more conductors. That means more size of the conductor. That means the more cross-sectional area of the conductor. That may require more copper or more aluminum. That means more conducting material. So whenever we are using normal conductor, or it may be using low power factor conductor, the low power factor conductor may use more conducting material than the normal conductor. That means whenever it may use more conducting material, that means the cost of conductor is also increases, right? So that is the greater conductor size. Because of greater conductor size, cost increases, efficiency decreases, right? Next one is so increased rating equipment. So the rating of the equipment is increased because for a system having low power factor, kVA and kilowatt capacity of the equipment are lower. So ఎప్పుడైతే పవర్ ఫ్యాక్టర్ తక్కువ ఉంటుందో kVA and kilowatt, why? Because cos pi is equal to kilowatt by kVA, right? So cos pi తక్కువ ఉందనుకో kilowatt కూడా తక్కువ ఉంటుంది. అదేవిధంగా kVAR కూడా తక్కువ ఉంటుంది. So kVA is equal to kilowatt by cos pi. So hence same amount of power, large kVA rating of the equipment is required, which make equipment is larger. So right, kVA rating equipment అనుకోండి సిస్టమ్ లార్జ్ సిస్టమ్ కూడా లార్జ్ అయిపోతుంది, దానివల్ల కాస్ట్ పెరుగుతుంది. సో దీస్ ఆర్ ది మెయిన్ డిసడ్వాంటేజ్ ఆఫ్ పవర్ ఫ్యాక్టర్. వాట్ ఆర్ దేర్? Large kVA rating of the equipment, greater conductor size, large copper loss, poor voltage regulation, reduced handling capacity. We may write any one. So that is, suppose I am explaining first this one, large copper loss. Second, so large kVA rating. Third, poor voltage regulation. Fourth, greater conductor size. Fifth, reduced handling capacity. So we may write any one, right? So now suppose I am increasing the power factor, I am increasing the power factor. So what is the benefits or what are the advantages of power factor improvement? Right? The power factor is low, which will increase the cost per unit supply the consumer. Right? So maintaining the high power factor is always advantageous for both consumers and the suppliers. So suppose I am the consumer, I am maintaining a good voltage profile, that is a good power factor in my house. So my neighbor also, because of me, my neighbor also utilized same conditions and they also maintain good power factor like that. Suppose consumers are maintaining good power factor, that may be effect on the supply system, that is distribution substation system also. Consumers are maintaining the good power factor is nothing but the substation also maintaining good power factor. So and vice versa is not possible. Suppose substation is maintaining good power factor, that may lose in the consumer side also. But consumers maintaining good power factor, total system power factor may be increases. The increase in the kilowatt capacity of the alternator and transmission lines. So already discussed, kilowatt is increases, whenever kilowatt increases, cost per increases, right? Active power increase అయిపోద్ది, reactive power తగ్గిపోద్ది, మనకు కావాల్సింది యాక్టివ్ పవర్. So right, the efficiency of the system is increased. So efficiency of the system may be increased enormously. Power losses are reduced due to reduction in the load current. KVA demand charges for the large consumers undergo reduction. Right? So that means increase system capacity and reduce system losses. ఎప్పుడైతే లాసెస్ తగ్గిపోయినాయో కెపాసిటీ ఇంక్రీజ్ అవుతుంది. Reducing peak kilowatt billing demand, eliminating the power factor penalty. So power factor, we have to maintain low power factor month by month. That may affect the our bill also, billing demand also. That means they identify the where the low power factor, more low power factor is available to the transmission line is nothing but the consumer one. So consumer one may got so many problems. That means they paying the bill more and more. That means penalty may be given to the particular person. Right? Increased voltage level in our electrical system and cooler, more efficient motors. So these are the advantages. Now what are the disadvantages, what are the improvements of methods of improving power factor? Generally they asking question like this: what is power factor, what are the causes of low power factor, and explain any two methods or any three methods of improving power factor methods. Otherwise they explain power factor improving methods, like that they asking total question. First, what is power factor, what are the causes of low power factor, what are the advantages of low power factor, and then methods to improve the power factor. Mainly in general there are different methods are available, but improving some of the methods are more important. That is static capacitor, synchronous condenser, phase advancers. These are the main methods: static capacitor, synchronous condenser, phase modifiers. Right? So look at the slide. Source of reactive power, that is inductive load, so may decrease the power factor, ante kada. So రియాక్టివ్ పవర్ ఎక్కువ ఎక్కడ ప్రొడ్యూస్ అవుతున్నాయి, ఎక్కడైతే లో పవర్ ఫ్యాక్టర్ ఉంటుందో. ఎక్కడ లో పవర్ ఫ్యాక్టర్ ఉంటుంది? ట్రాన్స్ఫార్మరు, ఇండక్షన్ మోటారు, ఇండక్షన్ జనరేటరు, డిశ్చార్జ్ ల్యాంప్స్. రైట్? సోర్సెస్ ఆఫ్ రియాక్టివ్ పవర్ మే డిక్రీజ్ ద పవర్ ఫ్యాక్టర్, but consumers of reactive power increase the power factor. Consumers may utilize capacitors, synchronous condensers, phase advancers. Right? So all these things may utilized to maintain the to decrease the power factor or increase the power factor. So what are the main methods? Static capacitor, synchronous condenser, phase advancers. Right? First static capacitor. We know that the static capacitor is nothing but simple one, economical one, easy design, easy replace for maintenance, right? Look at the figure like this, practical capacitors. So generally the static capacitor is nothing but power factor can be improved by connecting a static capacitor parallel with the supply or consumer. So whenever the power factor low for a particular system, it may running with low power factor. So when that is nothing but it is lagging the system. Suppose I am connecting capacitor across the supply, across the equipment. So capacitor is connected across the supply, across the equipment. That may lead to increase the power factor. That means capacitor is having leading wires or leading system, but equipment having lagging power factor. So now capacitor having leading power factor. This leading power factor may neutralize the lagging power factor such that the power factor may comes to the unity nearly. The capacitive current having leading nature, that may be neglected. Sorry, that may be reducing the equipment lagging power factor such that total equipment power factor may comes to the unity, right? So look at this slide. Most of the loads are inductive, that will take the lagging current which increase the system power factor, right? For the power factor improvement purpose, static capacitor are connected in parallel with the devices which work on low power factor. ఏ డివైస్ అయితే లో పవర్ ఫ్యాక్టర్ దగ్గర పనిచేస్తుందో ఆ డివైస్కి మనం అక్రాస్గా స్టాటిక్ కెపాసిటర్ని కనెక్ట్ చేస్తాము. With those devices which work on low power factor, right? These static capacitors provides leading current which neutralize the lagging current, right? Component neutralize the eliminate the lagging component of load current. Thus may power factor of the load circuit is improved. So right, which equipment is working with low power factor? So you have to identify it first. After then the shunt capacitor or static capacitor is connected across the supply. So now this static capacitor having leading current. So this static capacitor leading current may neutralize the lagging current of device. So now the total device power factor may comes to the nearly unity, right? These capacitors are installed in vicinity of large inductive loads, that is induction motors, transformers, etc. to improve the power factor, to improve also. So look at the figure 1 and figure 2, figure 3. Figure 1, it is the only resistive before connecting the capacitor resistive network. Figure 2, I am connecting a capacitor, so in between the sending end and receiving voltages, right? Current IC is flowing through the capacitor with leading angle of 90 degrees. So then from supply, the load current I, the vector combination of I and IC is nothing but I dash, which is lagging from the voltage at theta 2. If the angle is theta is less than theta 1, theta 1 అనేది 90 degrees అనుకున్నాం, theta 2 అనేది 45 degrees అనుకున్నాం. ఏమవుతుంది? cos 45 is greater than cos 90. 1/√2 is greater than 0. Therefore load power factor is improved by a capacitor. Load power factor అనేది కెపాసిటర్ ని చేసుకొని ఇంప్రూవ్ చేస్తుంది. After the power factor improvement, the circuit current would be less than the from the low power factor circuit. So before after the power factor improvement, the active component of current may be same in the circuit because capacitor eliminates only the reactive component of circuit. So capacitor అనేది reactive component reduce చేస్తుంది, అంతేగాని యాక్టివ్ కాంపోనెంట్ ఇంక్రీజ్ చేయటం లేదు. రియాక్టివ్ పవర్ రిడ్యూస్ చేయడం వల్ల పవర్ ఫ్యాక్టర్ ఇంప్రూవ్ అవుతుంది, కిలోవాట్ టచ్ చేయటం లేదు, రైట్? ఆల్సో ద యాక్టివ్ పవర్ వుడ్ బి సేమ్ ఫర్ ఆఫ్టర్ అండ్ బిఫోర్ ద పవర్ ఫ్యాక్టర్ ఇంప్రూవ్మెంట్. పవర్ ఫ్యాక్టర్ ఇంప్రూవ్ చేయకముందు పవర్ ఫ్యాక్టర్ ఇంప్రూవ్ చేసిన తర్వాత యాక్టివ్ పవర్ ఏమైనా చేంజ్ అవుతుందా బాబు అంటే ఏం చేంజ్ కాదు, దానికి సంబంధమే లేదు. విఐ కాస్ పై అలానే ఉంటుంది. చేంజ్ అయ్యేది ఏంటంటే రియాక్టివ్ పవర్ ఈజ్ రెడ్యూస్డ్. Whenever reactive power is reduced, angle is also reduced. Whenever angle is reduced, power factor may be improved. Anonymous. Now, what are the advantages of static capacitor? Is nothing but, so first of all, losses are very low, and there is a no moving part, therefore need to maintenance, low maintenance, easy installation with normal conditions, do not require a foundation for installation. They are lightweight, that's why easy maintenance also. What are the disadvantages? Nothing but service life, less service life. The service life of capacitor bank is less, that is 8 to 10 years. With changing load, we have to on off capacitor's bank, which may cause the switching surges on the system. Its repair is uneconomical. Officially, to control the switching positions of the capacitor, we may use. This is the static capacitor. On calculation of power factor correction, how to calculate the power factor correction? So like this, taking the power triangle, right? So before correcting the power factor, so OC is not available. Starting the triangle OAB, active power is kilowatt, reactive power is kVAR1, apparent power is kVA1, right? Now I am reducing the reactive power. I am not changing the active power. I am reducing the reactive power. kVA1 is reactive power, apparent power 1. Now kVA2. So AC is nothing but reactive power of component, that is kVAR2, right? Now, to leading the kVAR supply power factor correction equipment, BC is equal to AB minus AC. AB kVAR1 minus AC kVAR2. What is kVAR generally? kVAR formula, kilowatt by kVAR is equal to sin pi is equal to kVAR by kilowatt by cos pi. Now kVAR is equal to kVA into sin pi. Otherwise, in terms of kilowatt into tan pi. kVAR is equal to kilowatt into sin pi. Otherwise, kilowatt into tan pi. Right? So kVAR1 kilowatt into tan pi 1 minus kilowatt into tan pi 2. Kilowatt is nothing but OA. So kW tan pi 1 minus tan pi 2. So this is another method, that is synchronous condenser method. Synchronous motor may act as a capacitor where at no load condition and over excited condition. At no load condition and over excited condition, the synchronous motor may be act as a capacitor. So in that situation, the total synchronous motor behaves as a capacitor, that is nothing but it will act as a synchronous condenser. So when synchronous condenser is connected across the supply voltage, then it draws the leading current. So automatically synchronous motor is connected across the supply is nothing, across the equipment is nothing but it may draw leading current. That leading current may neutralize the equipment lagging current, then power factor may comes to nearly equal to unity, right? Because of this one. So it may reduce the reactive power only, it does not touch the active power, right? So look at the figure, three-phase load, so R, Y, B, and this is a three-phase synchronous motor current, all right? Now what are the advantages of disadvantages of synchronous condenser? You know that it gives the lifetime more compared to the static capacitor. That means It gives long life, that is 25 years. So high reliability, synchronous condenser, working with 25 years almost, and it gives high reliability, stepless adjustment of power factor. So no generation of harmonics. The faults can be removed easily. It is not affected by harmonics. Requires low maintenance. What are the disadvantages? It is a very expensive one. Why? Because synchronous motor, and maintenance also very high. Mostly used by large power users only. Last one is phase advancer. Phase advancer is nothing but simply AC exciter and is connected to the main shaft of the motor that may offer the with motor's rotor circuit for power factor improvement. Phase advancer is used to improve the power factor of induction motors only, not a synchronous motor, not a static capacitor. Phase advancer is nothing but it is improved to improve the power factor of induction motor in industries. As the stator winding of induction motor takes a lagging current 90 degrees out of phase with voltage, therefore power factor of the induction motor will be low. Right? Now if the exciting ampere turns are excited by the external AC source, then there would be no effect on the exciting current. So that means therefore the power factor of induction motor will be improved. This process is done by the phase advancer. What is the advantage? It means lagging kVARs run by the motor is substantially reduces. ఎప్పుడైతే kVAR reduce అయిందో ఏమవుతుంది? Power factor improve అవుతుంది. The phase advancers can be easily used where the use of synchronous motor is unacceptable. ఎక్కడైతే synchronous motor ని యాక్సెప్ట్ చేయరో పవర్ ఫ్యాక్టర్ ఇంప్రూవ్ చేయడానికి అక్కడ phase advancer యూజ్ చేస్తారు. What is the disadvantage? Using phase advancer, it is not economical of motors below 200 HP. Nearly about 150 kilowatts. Phase advancers ని ఎక్కువగా ప్రిఫర్ చేయరు. 200 HP కంటే తక్కువ ఉన్న మోటార్స్ ప్రిఫర్ చేయరు. ఒకవేళ ఎక్కువ ఉంటే ప్రిఫర్ చేస్తారు. Okay student, today class is now I am ending. Is there any doubts? Please ask me. Now in this class I am explaining just what is power factor, what are the definition of power factor, what are the causes of low power factor, what are the advantages of low power factor, high power factor, what is the advantage of high power factor, and what are the methods to improve the power factor. So question will be asking single question for 10 marks. So what are the causes of low power factor and explain any improving methods of power factor. At that time we have to write all the things: static capacitor, synchronous condenser, phase advancers, right? Thank you. Is there a doubt? Please ask me, otherwise so you may leave the class. So once again, please one minute.